Hi everyone, in this video we have a function f of x equals x squared plus 2x divided by x squared minus 16, and you have to find a lot of things. The first one is the domain, x-intercept, y-intercept, increasing, decreasing, inflection points, concavity, and graphing. So we will start with part A, which is the domain. In our function we have numerator and denominator, and as you know, to find the domain you have to put the denominator not equal to 0. So we have x squared minus 16 not equal to 0. By factorization and use difference between two squares, we have x plus 4 times x minus 4 not equal to 0. Then the first one not equal to 0 and the second one not equal to 0. So we have x plus 4 not equal to 0 and x minus 4 not equal to 0. And for the first one we have x not equal to negative 4. For the second one we have x not equals to 4. So this is our domain, or we can write it as all real numbers except plus minus 4. For the second part you have to find the x-intercept, and the x-intercept means you have to put the function equal to 0, but you have to simplify firstly. So we can simplify f of x as, for numerator you have to take x as greatest common factor multiplied by x plus 2. For numerator this is difference between two squares, so you have to write it as x plus 4 multiplied by x minus 4. Next, there is no common between numerator and denominator, and since x-intercept means that this function equal to 0, it means numerator equal to 0. So we have x multiplied by x plus 2 equal to 0. So we have x equals 0 or x plus 2 equal to 0. X equals 0 is ready. X plus 2 equal to 0 means x equals to negative 2. So we have two x-intercepts occurs at the point 0, 0 and negative 2, 0. And in part C you have to find the y-intercepts. So the y-intercepts means you have to put x equals 0. So you have to replace the value x equals 0 in the function f of x. So f of 0 equals 0 squared plus 2 times 0 divided by 0 squared minus 16, which is 0 over negative 16, and 0 over negative 16 equal to 0. So we have the point 0, 0 as a point have y-intercept for the function f of x. In part D you have to find the vertical asymptote lines and horizontal asymptote lines. The vertical asymptote line is zeros of denominator after simplify the function. So we have f of x equals to x multiplied by x plus 2. This is the factorization of numerator, and the factorization of denominator is difference between two squares. So we have x plus 4 multiplied by x minus 4. No simplify for this function because no common between numerator and denominator. So you have to find the zeros of denominator, and these zeros will be the vertical asymptote lines for this function. So you have to put denominator equal to 0 Then we have x equals to -4 and x equals to 4. This is the first vertical asymptote line, and this is the second one. For part E, find the horizontal asymptote line. To find the horizontal asymptote line, you have to find the limit of f of x when x goes to positive or negative infinity. So we have limit f of x, x squared plus 2x divided by x squared minus 16 when x goes to positive or negative infinity. When limit at infinity, so you have to take the highest power up and the highest power down. So we have x squared divided by x squared when x goes to positive minus infinity, and this is equals to 1. So we have y equals to 1. This is the horizontal asymptote line. Pay attention, horizontal asymptote line is y equals a number, and vertical asymptote line is x equals a number. So pay attention for that. In part F, you have to find what is the behavior of the function of x around the vertical asymptote lines. So you have to read what is the sign of the function f of x. So we have numerator x squared plus 2x equal to 0. So x multiplied by x plus 2 equal to 0, and we have x equal to 0 and x equals to negative 2. So this is the sign of numerator. We have minus 2 and 0, and since the numerator is a quadratic function, so between two roots we have negative, and out we have positive. This is the sign of numerator, and in denominator we have the function x squared minus 16. So we have the roots x equals negative 4 and x equals to 4. So negative 4 is to the left of negative 2 and 4 to the right of 0. So between the roots we have different sign from the coefficient of x squared. So we have negative, and out of roots we have positive. This is the denominator. Now for the function f of x, this is the sign of the function f of x. We have negative 4, we have negative 2, 0 and 4. So you have to divide to get the sign. Positive divide by positive, so this is positive, positive divide by negative, negative, negative divide by negative, positive, and positive divide by negative, negative, and positive divide by positive equal to positive. The vertical asymptote lines are x equals to 4 and negative 4. So to the right of negative 4 the function goes to negative infinity. So we have f of x goes to negative infinity as x tends to negative 4 from right, and f of x goes to positive infinity as x goes negative 4 from left. And for the second asymptote line we have x equals to 4. So to the right of 4 we have positive infinity, and to the left of 4 we have negative infinity. So f of x tends to positive infinity as x goes to 4 from right, and f of x goes to negative infinity as x tends to 4 from left. In part G, you have to find the critical points. And to find the critical points, firstly, you have to find the first derivative, f prime of x. And f of x is a rational function, so you have to use the quotient rule to find the derivative of this function. So you have to name the numerator as u and denominator v. And this is the quotient rule. So the derivative of our function equals uv minus uv prime divided by v squared. And this is equals to u prime, which is the derivative of numerator, and we have 2x plus 2 multiplied by v, and v is x squared minus 16 minus u times v prime, and u times v prime, u is the same function up, x squared plus 2x multiplied by v prime, the derivative of the denominator is 2x divided by the denominator square, x squared minus 16 to the 2. Now you have to simplify the numerator. You have to multiply these two brackets. So we have 2x squared times 2x times x squared, 2x cubed minus 2x times negative 16, 32x. Then you have to multiply 2 by x squared and negative 16, and you will get plus 2x squared minus 32. Then for the second one also you have to multiply 2x by brackets, but pay attention for the negative sign here. So we have negative 2x cubed minus 4x squared divided by x squared minus 16 squared. Now we have 2x cubed minus 2x cubed equal to 0. Also we have similar terms. These are negative 32x. There is no similar to negative 32x. We have 2x squared and negative 4x squared, and this is equals to negative 2x squared. We have only negative 32x have x term, so we have negative 32x. Then we have only one constant, which is negative 32 divided by x squared minus 16 squared. The last simplify for the first derivative is to take greatest common factor between these three terms, and the greatest common factor is negative 2 multiplied by x squared plus 16 x plus 16 divided by the denominator x squared minus 16 squared. In part G, you have to find the critical point. Okay, so we did f prime, and this is f prime, and now you have to make a numerator equal to 0 and denominator equal to 0. for the function f prime, because if you want to find the critical points, it must be in the domain of the function f of x and make the function f prime of x equal to 0 or does not exist. F prime of x equal to 0 means numerator equal to 0. F prime of x does not exist means the denominator of f prime equal to 0. So we will start with a numerator, and I will put a numerator equal to 0. So we have negative 2 multiplied by x squared plus 16 x plus 16 equal to 0. Divide both sides by negative 2. You will get x squared plus 16x plus 16 equal to 0. Now you have to use the general rule to find the solution of this quadratic equation, because you cannot find two numbers, multiply of them 16 and sum of them equals to 16. No such numbers. So x equals to negative b plus minus square root of b squared minus 4ac divided by 2a. So we have x equals to negative b, this is a, equals coefficient of x squared, this is b, and this is c. So negative b, it means negative 16 plus minus square root of b squared, 16 squared minus 4 times a times c divided by 2 multiplied by a, which is equals to 2. So we have x equals to, this is the first x, negative 8 plus 4 square root of 3, and the second root is negative 8 minus 4 multiplied by square root of 3. And by using calculator you can also find the root of this quadratic function by using mod 5 3. So by calculator x1 equals approximately equals to negative 1.07, and x2 approximately equals to negative 14.93. So this is the numerator. Now you have to put denominator equal to 0 also to find the zeros of denominator. Denominator is x squared minus 16 squared equal to 0. Take square root for both sides, you will get x squared minus 16 equal to 0, and then by solving you will get x equals to 4 and x equals to negative 4. Now from part A, the domain of this function is all real numbers except x equals to negative 4 and 4, and so x equals to 4 and negative 4 are not critical numbers. So we have the critical numbers are x1 equals negative 8 plus 4 square root of 3, and x2 equals negative 8 minus 4 square root of 3. So only these are the critical numbers of the function f of x. But the question is to find the critical points not the critical numbers. So you have to replace x1 and x2 and the function f of x to find the critical points. So now you have to use calculator to replace these values. So by calculator I have that f of x1 equals to 0.07 and f of x2 equals approximately 0.93. So what are the critical points? Critical points is negative 1.07 with its image, which is 0.07. This is the first critical point, CP1, and the second critical point is negative 14.93 with its image, which is 0.93. This is the second critical point. So in this example we have two critical points, and these are the critical points of our function. Part H, you have to find the increasing and decreasing intervals, and this depends on the sign of f prime of x. If f prime is positive, then we have an increasing interval, and if f prime is negative, we have a decreasing interval. So first you have to read what is the sign of f prime. We have numerator and denominator. As in the previous part, we have the zeros of a numerator are negative 1.07 and negative 14.93. So you have to write them on the number line. We have negative 14.93, and secondly we have negative 1.07. So between roots, since we have a quadratic equation, between roots we have the different sign from the coefficient of x squared. So we have positive here, and here we have negative sign. For denominator we have x squared minus 16 squared, since this function to the power 2, so it's positive all in the number line. So we have x equals 4 and negative 4 as zeros of this function. Pay attention the order of the numbers. So negative 4 is here, and 4 to the right of negative 1.07, and this function is positive everywhere. Now you have to find the sign of overall function f prime. So f prime is numerator divided by denominator. So you have to put the numbers negative 14.93, then we have negative 4, we have negative 1.07, and we have 4. Then negative divided by positive, it will be negative. Positive divided by positive, we have positive. Positive divided by positive, we have positive in this interval. Negative divided by positive, negative, and negative divided by positive will be negative. So this is the sign of the function f prime, and hence this interval the function f is decreasing, and this interval it will be decreasing, decreasing. Here we have decreasing and decreasing. So we have 2 increasing interval and 3 decreasing interval. So f of x increasing on the intervals from negative 14.93 up to negative 4, and from negative 4 up to negative 1.07, and the function f of x decreasing in 3 intervals, and these intervals are from negative infinity to negative 14.93. The second one we have negative 1.07 up to 4, and the third one is from 4 up to infinity. In part I, you have to classify the critical points, okay, maximum or minimum. These are the critical points from part G. We have negative 14.93 and negative 1.07. So between decreasing and increasing we have local minimum, and between increasing and decreasing we have local maximum. So the local max equals f of negative 1.07, and this is equal 0.07, and we have local minimum equals to f of negative 14.93, and this is equal 0.93. In part J, you have to find the concavity intervals, and to find concavity intervals you have to find f double prime for the function f. From the previous parts we have f prime equals negative 2x squared minus 32x minus 32 divided by x squared minus 16 squared. So as homework, because it's not easy to find f double prime and you have to use the quotient rule to find it, so it is homework for my students to find f double prime of x, and f double prime of x equals to 4 multiplied by x cubed plus 24 x squared plus 48x plus 128 divided by x squared minus 16 squared cube, sorry. So this is the second derivative of the function f of x. Now to determine the concavity, if the function concave up or down, you have to make a numerator of f double prime equal to 0 and denominator equal to 0. So you have to put a numerator equal to 0 and denominator equal to 0. So numerator equal to 0 means that this cubic equation equal to 0, and using calculator with mode 5-4 in Casio calculator, you will find that we have a root which is x equals to negative 22.09, and for denominator we have x equals plus minus 4. Now negative 22.05, it is in the domain of our function, but plus minus 4, it is not in the domain of our function. To find the concavity for this function, you have to read the sign of this function, the sign of f double prime. So pay attention, you have to take the zeros of numerator and denominator. So this is a number line, and we will read the sign of the function f double prime of x, and we have 3 zeros from numerator and denominator. The first one negative 22.09, and the second one is negative 4, and finally we have 4. Now you have to take points in each of these intervals to check the sign of the function f double prime. So here we can take negative 5, and you have to find f double prime of negative 5, and by using calculator it approximately equals to 1.99, which is positive. And you can take 0 between negative 4 and 4, so f double prime of 0 equals to negative 1 over 8. So in this interval we have negative sign for the second derivative. Then you can take 5 in this interval and check the sign of f double prime, and using calculator f double prime equals to 6. So this interval is positive. And for the last interval here you can take negative 23 and find f double prime of negative 23, and approximately it's equals to negative 0.00001. So it is a negative number. So it is negative. Now we have to check and to find where the function f of x is concave up or concave down. This depends on the sign of f double prime. If f double prime is positive, so the function f will be concave up, and if the f double prime is negative, so the concave will be down. So in the first interval here it will be concave down, okay, and here concave up, here concave down because it's negative, and here will be concave up. So the function f of x concave up on the interval from negative 22.09 to negative 4, and from the interval 4 to positive infinity, and f of x concave up in the intervals, concave down, sorry, concave down and the intervals from negative infinity to negative 22.09, and from negative 4 to 4. These are the concavity intervals in which you have to deal with f double prime or the sign of f double prime to find these intervals. In part K, you have to find the inflection points, and to find the inflection points you have to find f double prime, and we did in the previous part, and you have to make numerator equal to 0 and denominator equal to 0. So we found that negative 22.09 is the 0 of numerator, and negative 4 and 4 are zeros of denominator, but negative 4 and 4 is out of our domain, so we have the point negative 2.09. So firstly, f double prime of this point is equal to 0, but you have to check if we have change for the function for the concavity. for our graph for f double prime, you can see that to the right of this point the function is concave up, and to the left of this point the function is concave down. So since we have change of concavity around this x, so this is an inflection number. So the inflection point is negative 22.09, and the image of this x value in our function. So you have to replace negative 22.09 in f of x, and using calculator you can find that the value of f of this x equals to 0.94. So this is our inflection point. Now we want to graph this function. So this is the summary of our work for the previous parts: the domain, x-intercept, y-intercept, vertical asymptotic lines, critical points, inflection points, increasing and decreasing. So firstly you have to put the points. The first point is 0, 0. We have also negative 2, 0. Then we have the point 0, 0, also it's y-intercept. Also we have the point negative 1.07 with 0.07, which is the critical point, the first one. Negative 1, almost here. This is the critical point. And we have negative 14 with 0.93 here. Also we have negative 7. We have negative 14. This is negative 14.93, and we have negative 22 with 0.94. .09. Now we will start this sketch, but before that you have to draw the vertical asymptotes. We have x equals to negative 4, almost here, x equals to negative 4. This is the first vertical asymptote, and the second one, x equals to 4. This is the second vertical asymptote line. Then we have y equals to 1 as horizontal asymptote line. So the curve from negative infinity to negative 22.09, decreasing and concave down. Then decreasing and concave up. This. After that, it's increasing and concave up, and 4 is negative 4, sorry, is vertical asymptote line. So we have like this. After that, after negative 4, we have from negative 4 to a negative 1.07, it is increasing and concave down. Then from negative 1.07 it is decreasing and concave down. Like this. After that, the last region we have from 4 to infinity, it is concave up and decreasing. So this is the graph of our function. It's